All right. Good morning, everyone. My name is Kyle Escamilla, and I am the training coordinator for EandM. I'd like to thank you for attending our webinar today focused on 6 safety sensors and solutions. After the webinar this morning, we will be doing a short Q&A, so please type any questions or comments you may have into the Q&A box or the chat box, and we will go over them at the end. Now I'd like to introduce your presenter for today's webinar, TJ Singh. TJ is a product specialist here at EandM. Good morning, TJ.
Hey, thanks, Kyle. You want me to get started?
Yeah, we're good. We're good to jump right in here.
All right, cool. All right, morning, everybody. Thanks for joining in again. And for today's webinar, we'll be doing it on safety sensors and safety solutions from SICK. A quick agenda. So it's more like a hybrid webinar, I would say. 25%, 20% PowerPoint, and then like 70 to 75 on actual software. So stay with me. I won't bore you. And the objective here is basically, I'll first go over the objective, then we'll do a quick overview of the sensors that I'm going to use for my demo. And then finally, we'll run down on the software on how I was able to integrate it and show you the value proposition here that SICK brings to the table. Again, objective is simply to give you details on the different capabilities of SICK safety sensors and how they can work independently as serial products, as well as work as a cohesive unit, combining a bunch of devices and add computation power with safety controllers to it. And also we'll go into the software side of it, where I'll show you how intuitive it is to program safety devices from SICK. And first we'll begin with the overview of the sensors that I'll be using for this demo. So the very first sensor is a safety scanner. I hope everybody's familiar with it. If not, I have a quick slide to also explain how safety scanners do work. But ultimately what they do is guard a certain perimeter, either horizontally or vertically, and safeguard people from any hazardous situations. And this safety scanner from SICK is the smallest safety scanner in the market, with the height profile of just 3 inches. And this can do protective fields of up to 3 meters. And there's a bunch of other functionality that can be added on top of the system with safety plugs. So real quick, I just want to show you, if you're not familiar with what safety scanners are. So ultimately, about a sensor working on time of flight. So what time of flight is, where in a sensor, it sends out a light pulse. The light pulse hits an object. The light pulse is reflected back by that object. Now, based on the time it took for the light pulse to go there and come back, since we know that and we know the speed of light, we are able to calculate the distance. And if you put the same sensor technology of time of flight inside a scanner, and effectively what happens in a scanner is there's a mirror that's spinning on a particular axis, and that laser is basically taking a horizontal profile of that area. So in that sense, you basically have the entire data points, and you're able to create like a virtual field around whatever area you're detecting. And that's how scanners work. If somebody infringes that field, it's going to trigger a stop, or some kind of output can be generated. The most common application for something like a safety LiDAR is going to be hazardous area protection. And you can see these nice visual representations here, in which if somebody gets too close to the press, it's going to stop the system. In the robot, you can have as a vertical field, and then point protection. So point protection is again what you do with your light curtains. Similar thing, but instead of having 2 sticks, you can just use a single unit on one side and create a vertical field. Next sensor that I do have in my demo as well is called a flex lock. Now, this is our newest safety interlock, which simply prevents operators or people from getting exposed to any kind of hazardous movement, and basically not allow them entry in a certain area or in a certain process. Ultimately, interlocks are used for 2 main applications, either people protection or process protection. So in person protection, like in this example, you can see of this like a wrapping machine here. You do not want anybody to enter it, right? So if you want to enter it, you need to stop the system. So how do you do that? You use an interlock which has a feature of press to unlock. So you press on that, the solenoid gets untangled, and then you're able to open the doors. And this is person protection. So when you're doing the same thing for process protection, there it's more like you do not want people to get stuck inside, right? So here we use mostly interlocks which have a power to release. So it just depends, but these are the most common applications for safety interlocks. One big feature of this new product that we have is the 180-degree actuation radius. And in this image, you can see you can actually insert it from any side or the front, and it also has a lot of tolerance for misalignment. So you can basically get away with with even some loose ends. And it's got some bright LEDs, which again are really cool for diagnostic purposes. You can see something from really far off, and I'll show you in the demo as well. Target applications, again, simple cells, process protection, as well as like a flatbed laser. So here, obviously, you do not want people to get exposed to any kind of class 2 laser or class 3 one, and then for that you want to make sure that, hey, press on the button so you stop the system, and then only can you enter it. Another side of the portfolio is non-contact safety switches, and these are more on the very popular side. It's our RFID non-contact switch. Effectively, it's a sensor and an actuator pair. On the actuator side, there's a RFID tag inbuilt, which basically allows you to make it tamper-proof. So no operator can tamper with it. Like in magnetic non-contact switches, they can just put a magnet and enter, or jam a door with something and still, for those electromechanical safety switches. So here you cannot tamper with it because it's RFID and it needs to see that particular data on the tag. That's how it works. And another really nice feature about this product is you have a bunch of options for the type of actuator you need. So you can see here from like a really standard one, you can go small sizes as well. And most commonly, where would you use them? For door monitoring, simply, or for also safe position monitoring to make sure you start a certain process when everything is properly aligned. Next product is the Flexi Compact. So now this one is our safety controller. One of them, actually, we have another one as well. But what makes this one pretty cool is the built-in I/O. So for this, you do not have to separately purchase I/O. You get inbuilt 20 inputs and around 12 outputs on board. You can always top it up with more I/O if you want, as well as diagnostic gateways if you were trying to get diagnostic bits over Ethernet. But ultimately, it's much more economical to have something on board rather than just having it separately. Something that's another unique to this safety controller is that it has a model in which which comes with a built-in port for Modbus TCP, so you can integrate it to an HMI or to a PLC directly to get any kind of diagnostics from your safety system. In terms of programming those devices, we use a software. It's called Safety Designer. You can manage the hardware configuration. You can do logic there, as well as you can generate a detailed report on everything from wiring to part number details, as well as what were the last events that triggered the stop, or who changed the configuration last time. So you can get a lot of data points. And we'll do the demo on the Safety Designer today. Some common applications where you would probably use one of the safety controllers is if you have multiple devices, you're trying to do some kind of a logical program there where you want to trigger stops on certain actions, right? And for some applications, like in this one, we also have another system that integrates with our safety controllers. It's called FlexiLoop. Now, that's the last thing I want to show you over the slide. And that's this FlexiLoop is, again, a very powerful tool. So think about from a perspective where you might have a lot of systems on site and you're trying to basically have a common stop for all of them. Because if, let's say in this application, if one of these doors opens, you want the entire system to be triggered. Now, what ends up happening is that you're trying, it's more like a central system, right? Because now you're running long cables and you need more IO on board. And there's a lot of complexity with that. And how we help with this is flexi loops. So those nodes simply allows you to have a series connection, which basically has just one IO, and that goes to your safety controller. So instead of this system, you can literally have something like this. So you can save up on all that wiring as well as complexity with our flexi loop nodes. And this is what a normal structure would look like: a safety controller, a FlexiLoop node connected in series with other nodes, and each node connected to a safety device. Can be any kind of safety device. And the best part is the system is brand agnostic. So you can just use any sensor or actuator from other manufacturers and use it on our system. All right, now we're gonna get into the cool stuff. So the demo. So I've created a quick demo for you guys where I have used a safety controller. And let me also switch the camera so you can actually see it while I talk about it. So what I have is a safety controller here. This is the safety controller that's connected to a node. A node is connected to this e-stop and a reset button. The node is further in series connected to a non-contact safety switch, and then that's further connected to another node which is connected to a safety interlock, which we and all these products we just discussed about right now. And then I have a separate thing which is a safety scanner, and I've connected that directly with the controller over IO. And this safety system is actually sending the output on the relay. So if something goes off, the relay is going to shut off the system. And with that, let me open up the software. Hey Kyle, the screen
Yeah.
should be visible, right?
Yeah, I see. It's a new program. It's not your presentation.
Yeah. So
Okay.
you see this, right? Okay.
Yes, I do.
All right. So so now what I'm going to probably do is right now is quickly create the configuration and the logic that I have on my desk right now, and then we'll run it on the live system, and I'll actually show you how everything gets triggered. But the point here is to show you how intuitive the entire setup is. So Safety Designer is the name of the software what we're using, and no matter what safety product you're using, all the newer ones are going to work on this same software. So that's a good part. Once you open it up, it's pretty straightforward. It's a left to right and top down approach. So left to right, you can see overview first. So overview would actually give you all the details once we are connected in terms of the part numbers and what configuration is on board. Next step is going to configuration. So now this is the page where we actually handle the what's going on in our inputs and outputs. So once you click on configuration, the hardware shows up. So this is what the Flexi Compact looks like. And here you have 20 inputs and around 12 outputs. The first step, what I used like to do is add modules. So now modules are your gateways to get more diagnostics. If you want to do over Profinet, you want to send it to your PLC or EtherCAT as well as CANopen. And if you have more inputs and outputs there, then you can also add and drag and drop this as well if you want to have more functionality. In our case, we're just going to use like 3 inputs. Or once you have the hardware, then next thing is elements. So now what elements effectively are, it's your inputs and outputs. So when I say inputs, we are going to assign the terminal on what we're going to connect to it, right? So in our case, if you remember the layout, what I had was safety LiDAR, the nanoscan, right? So I can just go here to electrosensitive protective devices and I click on it, and you'll see a bunch of devices in the drop-down menu. Now, these are all SIG devices, obviously, but what you have to understand here is that at the end of the day, these are just placeholders. So all the devices that have, let's say, a OSSD output, a safety dual channel pulsing output, that's going to have this. You can use any of this. It's just a placeholder. So it doesn't matter what I use. I'm just trying to tell the system that, hey, on I3 and I4, while I drag and drop on it, expect a dual channel pulsing output. Okay. So once I add this input, the next thing I had in my system was a flexi loop, right? So I had flexi loop, which was connected to 3 different devices. So we'll add that as well. So now, real quick on flexi loop, it basically creates a data point on 3 terminals, right? So one is our test pulse, which runs through the entire series circuit. Then is a data input as well as a safe input. And another one thing that you should always do, and I usually do it, is configuring the output. So now, in terms of outputs, obviously I'm connecting it to a relay, but again, these are placeholders. So I have a dual channel relay, so I can just use this dual channel robot here, and that will basically trigger my relay once I have my logic in there. So I already have one input, which is my safety scanner on I3 and I4. Next step is to configure the flexi loop. Now, for flexi loop, again, I said left to right and top down approach. So in configuration, now we go top down. Here you see flexi loop. Once you click on flexi loop, you can see similar hardware and input output options show up, right? So in this, what happens is with flexi loop, you actually have options of selecting what kind of safety device that you're using. And based on that, we have 4 flexi loop nodes. So we call them nodes. So what EMSS stands for is electromechanical safety switch, which can be your dual channel normally open contact or normally closed contact, and then OSSD outputs can be your safety outputs. And then we have similar variants in EMSS 5 and 8. Effectively, what 8 means is that you have more than 5 pins that you want to use, right? So to configure our system, in my first node, I have a EMSS 8. Why? Because, and I just have to double click on it and it shows up on here, right? So in this, what I have is a e-stop with a reset. So now if I go to elements and open up my inputs, I already have those options. All I have to do is click on my e-stop and reset, drag and drop on it, and you can see a dual channel e-stop as well as one reset button came up. And if you notice here one more thing, there's another terminal available, which this signifies output. So now, since my reset has a LED on it, so what I can also do is go to the outputs here, click on this electrical symbols and drag this lamp on top of it. So now what I will do is, hey, if I need to trigger a reset, turn on the light as well. So you can also customize these things over the flexi loop nodes. So once I have this here, the next node I have is a sorry OSSD 5. Now OSSD is basically obviously a dual channel safety output. And for that, I have a non-contact safety switch, which is called STR1. And if I go in the elements again, in my inputs, I already have these options right here listed for me, non-contact switches. So what I can just do is STR1, hey, I'm using this, drag it, and that's it. And lastly, what I also have is a safety interlock. Now, if you think about it, now my safety interlock has a dual channel safety output along with interlock, right? So now I have to control the interlock. So that's why I need one extra pin. So I have OSSD 8 instead of 5. And then for that, again, go to elements. And the elements, you can simply go to interlocks. And right here, you have all the other options available. So I have this one, flex lock. And like I mentioned, again, it's not that this has to be exactly the same name. Like you can use a generic interlock from some other manufacturer, but mostly all the standard ones will have the same IOs. Like you will have your pin 2 and 4 for your OSSDs, and then you'll have the other pin, maybe 5 or 6 for your controlling the solenoids. So it's going to match out in most cases. Once this is done, we are almost done with this part. You can click on configuration again. So once you click on configuration, now you have already set your IO for the main flexi compact as well as the loops. Next thing what you will do is go to logic editor. Now logic editor is where you define all the functions. What do I want to do? So in my case, I'm going to do a very simple function. So on the right side of this logic editor, you have inputs, function blocks, outputs, and diagnostics. So again, go top down. What I like to do is go to my inputs. And if you see here, flexi compact, and underneath that tab, I have a loop. So I already have the loop. Inside the loop, I have a flexi loop. This is the entire safety channel, as well as a single channel input, which is a normally open one. And if I'll just drag it and drop it here. And if you remember, this was our reset from the flexi loop module. And underneath that, I also have nanoscan, which is my safety scanner. If you remember, I added that as well. And I drag it and drop it here. So for just for better visualization purposes, I'm going to use the flex diagnostics. And so I also have what? E-stop. I have an e-stop there, right? On my one node, I have my STR1 on another node, and I also have my safety interlock. So all these inputs, I just dragged it and put it here. And if you remember, I also had some outputs. What output I had? I had a lamp, if you remember, for the reset, right? For the reset, I had the lamp here to turn on the light when a reset is required. And I also had the interlock where I will send a signal to it to unlock the system. And lastly, I had the safety relay, which is represented here by like a robot output. And that's all the IOs that I have. After you do that, all you have to now do is go to function blocks. Now, SIG has already created these function blocks for you, which handle most of the configuration that you're trying to do here. So in my case, I'm doing a simple AND logic. All I'm going to do is drag and drop an AND logic here. And now it has two inputs, one output. The output obviously going to connect to it's going to connect to my robot, right? Because that's what I want to turn on if everything works properly. And for inputs, now I only have two, right? So I have 4 inputs here. How do I change that? You just click on, right click on it, edit it, and you can actually increase the number of inputs that you have. And once you do that, so again, this is very flexible, right? Like you can make modifications to the pre-created function blocks. And these function blocks are quite intuitive to understand. And another thing is for the reset, right? So now this is my reset. I can also add a reset functionality here, like let's say a reset here. Now, what a reset does for that, obviously, now think about it. If everything's, if all my safety devices are working, then I want to send that signal to the reset rather than going to the robot directly. So I'll delete that and I'll connect it to my reset logic. Now, how the logic would work, which is already pre-programmed, is that if all these devices are working, then trigger the reset. Now, reset can be triggered by this button, which is a normally open one. And this will obviously, if the button is pressed, should enable my robot and it should start working. But what I'm missing now, lamp, right? So this was to trigger, hey, reset is required. So for that, it's very clearly mentioned here as well, reset required. So all you have to do is connect that to this output. Now your light will turn on. And that's pretty much it. You're almost done. Now, one thing which is still remaining is that interlock. Right now, that's a solenoid lock, and I'm trying to control the power to release feature. So how do I control that? Now I need to trigger this. So for this, I can have another normally closed input, which again, I'll just go to my elements, go to my inputs. Now there's some pre-created ones. So you see in potential, free, contacts, and restart. So you have a bunch of these single channel, normally open ones. All I'm going to do is just drag one and drop it here. So now go back to the logic editor, and this should show up in my inputs, right? So in my inputs now, not the flexi loop one, but this thing came up. So I just bring it here. So if I press on this button now, which is my normally open, I will trigger this interlock to work. And you can also simulate it before I actually get into the and connect to the device. If I simulate it, how I want it to work is my interlock is good, my non-contact safety switch is good, my e-stop is good, and my safety scanner is good. It gives the signal to my reset block. Hey, everything is fine. Lamp turns on, press on the reset. I press on the reset, I release the normally open one, and boom, the robot starts working. Now, one thing is here where if you press on this button, your interlock should open. Now, that obviously cannot be simulated. For that, we actually need to have the actual system. So now, this entire system in its working, if I bring my how the actual layout is right now, if you look at my camera here in the camera, if I go in this screen, if you can see my hand. So right now, what's being triggered there? The lamp, right? And you can see this lamp is turning on. This is flashing, and on the software also. So now the relay just turned on. So now everything is good. But what happens if I take the non-contact safety switch away from it? Now it turns off the robot in this sense, right? Because it's turning off the safety relay. And if you can see it's red, now I bring it back and it should turn green on the software too, the flexi loop. And now what's gonna do? Hey, press on the reset and ready to go. So now I also had the flexi flex lock, which was controlled by a button, right? Which was normally open. So this unlocks it. So now I can actually take it out, and this bright LED shows you, hey, don't have the lock in there. So now I can insert it back in. It's green. Hey, I have the lock back in, but the release button is not pressed. So now if I, and it locks back in. And you will see again, hey, press on the reset. And the last thing I have is the scanner, right? So now in the scanner, if I come too close, it stops. And if I get out, it's again showing the same thing, press on the reset. And yeah, that's pretty much it. I know it was quite quick, and I hope I was able to explain this properly, but we can take in questions. We still have, I think, some time.
Awesome. Yeah, thank you, TJ. Yeah, we did hit 10:30 here, but we do want to provide the opportunity for anyone who has any questions they'd like to have answered. Feel free to write your question in the chat, or you can use the Q&A box. We can get your questions through either of those. So we'll just hang out for a sec if in case anyone has any burning questions. Okay, we got one that came in here just now. Someone asked, can you change the configuration on the Flexi Compact over Ethernet?
Yes, so you can do that. That's why we have that port for the Modbus TCP, so you can use that and also connect it over serial, how I have it right now, but those are available options.
Awesome, awesome. Okay, one person here. Can magnetic safety switches also work with the Flexi Loop?
So yes, again, so it's technology independent. Like it doesn't matter what technology that safety sensor is, everything can work as long as our inputs match with it and the configuration matches. And most of the time, it's all standard, and I've always seen it to work.
Awesome, awesome. Just give another minute here in case anyone else has anything. All right, well, if anyone has anything, they can still ask while I close things up here. But I'd just like to thank you, TJ, and I'd like to thank everyone else who attended. If anyone would like to review any portion of this webinar, a recording will be available on our YouTube channel and as well as our website, EandM.com. Once it's available, you will also be receiving a copy of it via email. I'd like to thank everyone for attending today and wish you guys all a great day.
Thanks, guys. Have a good one.
Have a good one.